Assalamualaikum warahmatullahi wabarakatuh. Today we will presenting our report or project report. I am Nur Syarafatia binti Zuli and my teammate is Nur Ashira binti Muhammad Bakri. So our project name is Algerian Forest Fire. So for the introduction, this mini project is made to find best fit curve for the Algerian forest fires dataset. Algerian forest fire dataset is a 4 month of observation to different region at 2 different region which name Bijaya and Sidi Bel Abbas. And then we will take the Bijaya region data only which it has a 122 data points. So this data has 11 variables, which is relative humidity, wind speed, rain, fine fill moisture coat, depth moisture coat, draft coat, initial spread index, build-up index, prior weather index, and then and temperature at noon. And so we decided to investigate on the relationship between temperature at noon and FW value. So our X is our independent variable is temperature at noon, and FWI value is our dependent variable. So we will show you how did we convert our data into Maple. So basically we are using the with Excel tools coding so that we can import our data into the Maple in the matrices form. And then this is for linear model coding. And then we will define our matrix M and matrix Y using the import code, and then we will find our least square solutions with matrix inverse M little m multiplied by transpose M multiply Y, and then we will find our error vector, and then we will find our error magnitude with vector norm E, like this. Okay, and then we will find our graph using width statistic. Okay, this is our scatter plot. This is how we got the scatter plot. And then this is how we get the this is how we define our best fit curve equation. Okay, so masuk code. We will move on to the quadratic model.
So on quadratic model, we use the same coding and we search the same things, which is we find the M value, we find the transpose M times M, Y, V, which is V is least square solution. Then we find the E, which is a error vector, and vector norm. Next is we convert X to the matrices form. Then we use the value to find the graph. We plot the graph. This is the scatter plot. Next is cubic model. Same goes to quadratic and linear. We use the same coding.
And so does quadratic model. All of them are using a same coding. So we will move on to our finding, which is implementation. First is our linear model. Y equal to A plus BX. We represent our matrix of above system like this. And then we have found the normal equation, and then least square solution, and then we got the best fit linear curve, which is y equal to negative 30.66 plus 1.20 x, and then we find the vector magnitude and so on. And then for the quadratic model.
Next is quadratic model. The data generates a system of quadratic equation with the matrix representation as below, which is the equation is y equal to a plus bx plus cx squared. Okay, firstly we find mv equal to y, then we find the normal equation is we use the formula m transpose m v equal to m transpose y. Then we find the least squares solution. Then we found that the best fit quadratic curve is y equal to 63.855 46744 94052. Okay, next we find the error vector. The last is error vector magnitude. Next is same goes to cubic model, but cubic model we use the equation y equal to a plus bx plus cx square plus bx cube. Okay, the same things we search the mv equal to y, normal equation, the least squares solution, error vector, and the last one is error vector magnitude.
And then for this implementation, we decided to do until a fourth degree mathematical model, which is a quartic model, which is y equal to a plus bx plus cx square plus dx cubic and plus ex quartic. Yeah. Right. All of it is the same. And this question, and then the vector magnitude. And this is our graph, the linear model, the graph of best fit curve against its observed data. So this is the linear model, the quadratic model, and then the cubic model, and lastly quartic model.
And then I want to explain about analysis and conclusion of this project. Based on the models is above, we obtain the following error magnitude of each model. So we got linear model 20.1829, quadratic model 19.1312, cubic model 19.1323, quartic model 18.95. So based on the error magnitude, we find that the best fit curve in this case, which will give the best approximation, is the quartic model because it has the minimum error in terms of its magnitude. Then this is the graph that produces minimum error, which is quartic model.
So that's all from us. Thank you.